All right, let's take a look at the practice test. For the instructions, we're asked to solve each for all solutions. All right, let's take a look at the first problem. So here we have 1 plus the sine of x is greater than, we have 2 minus the square root of 2 over 2. So this type of problem is an easier problem. You can just solve it by isolating the sine of x on one side and putting a number on the other. You could also use the test point method, which we're going to see later on, but I wouldn't recommend that in this situation because it's just so easy. So the first thing I'm going to do is multiply both sides of the inequality by 2. That's going to clear this denominator right here. So I'm going to go 2 times 1 plus 2 times the sine of x, and this is greater than, you have 2 minus the square root of 2 over 2, and then times 2. So 2 times 1 is obviously 2, and then plus you just have 2 sine of x, and this is greater than, here the 2's would cancel, so you just have your numerator, so 2 minus the square root of 2. Now at this point, notice you have a 2 here and a 2 here, so you can subtract 2 away from each side of the inequality. So basically this is going to cancel, and this is going to cancel, and what you're left with is 2 sine of x is greater than the negative of the square root of 2. All right, so I'm going to divide both sides of the inequality by 2 so I can completely isolate the sine of x. So this cancels, and you're going to get that the sine of x is greater than the negative of the square root of 2 over 2. Okay, let me come down here and paste this in. When you solve an inequality like this, the first thing I would do is think about the period for what you're working with. So if you just have something like the sine of x, remember, if I was solving, let's say, the sine of x equals the negative of the square root of 2 over 2. This is just the standard period of 2 pi, so solutions repeat every 2 pi. So if I solve this equation here to see where the sine of x is equal to the negative of the square root of 2 over 2, I'm going to go into quadrants 3 and 4, where sine is going to be negative, and I'm looking for a reference angle of pi over 4. So at 5 pi over 4, I'm going to have that reference angle of pi over 4. Notice your sine value here is negative square root of 2 over 2, and then at 7 pi over 4, I'm going to have a reference angle of pi over 4, and so your sine value is negative square root of 2 over 2. Now, if you look between these values here, this inequality is not going to be satisfied. In other words, it would produce a false statement. So if I look at the sine values between 5 pi over 4 and 7 pi over 4, you notice you get negative square root of 3 over 2, negative 1, negative square root of 3 over 2. So obviously that is not greater than negative square root of 2 over 2. So this would not work. So what you want to focus on is the part of the unit circle where it would work. So where the sine values would be greater than the negative of the square root of 2 over 2. So that's going to be right here. Now, the way you're going to write this is going to be a little bit tricky. So let me go ahead and highlight all of this first, and then let's talk about it. So basically, when you look at this, you would start, or you could start, I would say, because there's different ways to write it. Let me erase this. You could start by saying that x is strictly greater than, let's put our 7 pi over 4 here. So 7 pi over 4, and I'm going to add that 2 pi n, so 2 pi n, that we put when we work with the general solution. So let me put that like that, and I'm going to say it's less than. Now here's where it's tricky. If you're just looking at the unit circle, you might be tempted to put 5 pi over 4 there. So really you have to think about it as, I'm starting at 7 pi over 4, so I've already rotated like this. So in other words, this is not 5 pi over 4, it's 5 pi over 4 plus 2 pi, which is 8 pi over 4 if you want a common denominator. So that's 13 pi over 4. So that's how you have to treat that right there. So let's go ahead and say that this part is going to be 13 pi over 4, and then plus 2 pi n. Now, this is one way to write it. You don't have to write it that way. When you go to the graph in a moment with me, I'll show you that there's obviously going to be lots and lots of ways that you could write this general solution. So what you could also choose to do is rotate clockwise here. So we all know that if we rotate clockwise here, this would be negative pi over 4. And basically we know that the sine of negative pi over 4 and the sine of 7 pi over 4, that's going to be the same. You're going to get that negative square root of 2 over 2 in each case. And so what you could do is say that x is greater than this negative pi over 4, and then plus your, I don't think I can fit this, so let me put the 2 pi n there. So 2 pi n, and then I'll put that back in, and less than, well now if I'm starting here and I've rotated clockwise here, so this is negative pi over 4, well now I can just do this rotation here, and that would be 5 pi over 4. So let's put 5 pi over 4, and then plus 2 pi n. And if this is a little bit confusing for you, don't worry about it. The first few times you do this, it is a little bit confusing to get your general solution. When we look at the graph in a moment, it'll make more sense. Let me get rid of this one. This is the one I'm going to go with because this is what I used in the practice test. Now, if you want to look at the graph of this, what you would do is think about this as an equation. So let's just say I had the sine of x is equal to the negative of the square root of 2 over 2. So let's say you had the sine of x plus the square root of 2 over 2. And basically, at this point, that would be equal to 0. And so a lot of times what we'll do is we'll say y is equal to this. Let me move this up here. And if you wanted to solve that equation that way, you're looking for where y is 0. So those are your x-intercepts. So you're going to see those at negative pi over 4. You're going to see 5 pi over 4. You're going to see 7 pi over 4. You're going to see 13 pi over 4. So basically, you can think about it as 5 pi over 4 plus 2 pi n and 7 pi over 4 plus 2 pi n, where n is any integer, if you're looking for the x-intercepts. But essentially, we're trying to solve the inequality. So we're trying to say, well, in this particular case, it would be where are the y values greater than 0? So let me grab this real quick. I already have the equation written, so we don't need to take that. And let's come down to the graph. So let's put this like this, just out of the way. And again, you can go to Desmos or any online graphing calculator and just type this in. Y equals the sine of x plus the square root of 2 over 2. Again, the x-intercepts, if you want to look at those, here's your negative pi over 4. Here's your 5 pi over 4. Here's your 7 pi over 4. Here's your 13 pi over 4, so on and so forth. So basically 5 pi over 4 plus 2 pi n and 7 pi over 4 plus 2 pi n, where n is any integer. Now, if we're trying to figure out where the y values are greater than 0, again, if you look at this piece right here, so between negative pi over 4 and 5 pi over 4, you're going to see that that inequality would be satisfied. So the y values are greater than 0. Again, if you look at this one right here, this is how we're listing the solution. So between 7 pi over 4 and 13 pi over 4, again, we're going to be greater than 0 in terms of the y values. So you have this piece and this piece and this piece, and that continues forever and ever and ever. So that's one way that you could write it like this. Or again, if you wanted to say that x is greater than your negative pi over 4, so this right here, plus 2 pi n, and less than your 5 pi over 4, so this right here, plus 2 pi n, where n is any integer, that's fine as well. Because again, if you take negative pi over 4 and you add 2 pi, you get to 7 pi over 4. If you add 2 pi, you get to 15 pi over 4, so on and so forth. If you take your 5 pi over 4 and you add 2 pi, you get to 13 pi over 4. Again, if you add 2 pi again, you're going to get to 21 pi over 4, so on and so forth. All right, let's move on and look at problem 2. So here we have 2 tangent of x is less than negative 2 times the square root of 3. So you can solve this just like the last problem, isolate the tangent of x on one side, have a number on the other, and then go to the unit circle and put your solution together. The problem with that is it's not as straightforward because the tangent values are not on the unit circle. So if you're somebody that has them memorized, you can do it like that. But what I'm actually going to do is use a table. So let me go ahead and slide down a little bit. I'm just going to divide both sides of the inequality by 2 to get things started. That would cancel. And you get that the tangent of x is less than, these 2's would cancel. So you get the negative of the square root of 3. Again, I'll come to the unit circle. You can't directly get the values for tangent from the unit circle, but what you could do is use your calculator. And I think all of you know that if you typed in the inverse tangent of, let's just make this positive. So let's go positive square root of 3. You're going to get pi over 3. And of course, that's coming from the fact that the tangent of pi over 3 is equal to the sine of pi over 3, which is the square root of 3 over 2, divided by the cosine of pi over 3, which is a half. So I'm just going to multiply by the reciprocal, so times 2 over 1. And so, of course, these 2's would cancel, and you're going to get the square root of 3. So where do I have a tangent value of negative square root of 3? Well, that's going to be in quadrants 2 and 4, where tangent is negative, and where I have a reference angle of pi over 3. So that's going to be at 2 pi over 3, and then also it's going to be at 5 pi over 3. So just keep that in mind. So if I was to ask you the tangent of x, where is that equal to the negative of the square root of 3? Again, if you want to solve this from 0 to 2 pi, like this, you would say x is equal to 2 pi over 3, and then 5 pi over 3. Now, for this one, you have to consider that the period for tangent is pi. In other words, I have this solution here. I rotate by pi, and I get to another solution. I rotate by pi, I get to another solution, and so on and so forth. So really for this problem, if I'm setting up a table or something like that, I don't want to go between 0 and 2 pi. I want to go between 0 and pi. That's all I need to do because the solutions are repeating every pi. So get rid of this and get rid of this. So I'm just going to consider that right there. Now, when I talk about making a table, essentially what you're doing is you're going to split this guy up into different intervals, and you're just going to test. So you don't have to do it this way. I just find it to be the easiest in this particular situation. So I'm going to go between 0 and pi, and I'm going to think about the intervals that I'm going to set up. So this right here would be a critical value. So that's basically where the tangent of x is equal to the negative of the square root of 3. But you also have to consider where the tangent of x would be undefined. So at pi over 2, in this guy right here, working from 0 to pi, well, basically it's going to be undefined there because the tangent of pi over 2 is equal to the sine of pi over 2 divided by the cosine of pi over 2. And the cosine of pi over 2 is 0. So division by 0 is undefined. So this becomes 1 over 0, which is, by definition, undefined. So this is undefined. Now, we have to include that in when we test. So let me get rid of this. And basically, let me line this out. So you're going to have an interval between 0 and pi over 2. So you're going to test in there and see if things work. And then you're going to have an interval between pi over 2 and 2 pi over 3. So you're going to test in there and see if it works. And then you're going to have an interval between 2 pi over 3 and pi, test in there and see if it works. So when I set these tables up, I don't include anything. I just include things if I need to at the end. I've already got the table set up. So I wrote this in a different way. It was the tangent of x is less than the negative of the square root of 3. I just added the square root of 3 to both sides of the inequality. So it produces this right here. And essentially, here are the intervals. And I've already picked out something in each interval. And I've plugged it into the calculator to speed things up. Essentially, you're just trying to figure out, is it positive or is it negative? Basically, if it's negative, it's going to work. It's going to be less than 0. And if it's positive, it's not going to work because it's not going to be less than 0. So in this interval between 0 and pi over 2, I chose pi over 6. And if you plug that into your calculator, you're going to get about 2.31. So this is positive. So this is not going to work. Then in this interval between pi over 2 and 2 pi over 3, I picked 7 pi over 12, which is going to be 105 degrees, in case you're curious. So basically, if you plug that in, you're going to get exactly -2. So this is negative, so this is going to work. And then between 2 pi over 3 and pi, in this interval here, I picked 5 pi over 6. If you plug that in, you get about 1.15. So this is positive, so this is not going to work. So if you want to put your solution together, again, you can do it here. I prefer to go to the unit circle. So just coming back here, let me erase this and this. So basically, this right here is where it's going to work. So this right here is where it's going to work. So between pi over 2 and 2 pi over 3, 2 pi over 3 will not be included because it's a strict inequality, and pi over 2 will not be included because that's where it's undefined. Because the period is pi, you're going to say that x is going to be greater than your pi over 2, so pi over 2. And now you got to put plus, what's the period for tangent? It's pi, so pi n. Don't make the mistake of putting 2 pi n because, again, the period for tangent is pi. Then we're going to say, and it's less than, you're going to use 2 pi over 3. So 2 pi over 3, and then plus pi n. Now, if you wanted to look at this, again, when we get to the graph, you're going to see this more obviously. If you take pi over 2 and you add pi, where you're adding 2 pi over 2, so that's 3 pi over 2. If you take 2 pi over 3 and you add pi, again, you're adding 3 pi over 3, so that's going to be 5 pi over 3. So you'd see that you have this piece that works, and then you have this piece that works between there. And again, you just keep adding this period here to each part, and you'll keep getting additional solutions. Now for the graph, what I'm going to do again is write this as the tangent of x. I'm going to add square root of 3 to each side, so plus the square root of 3. We'll say that's less than 0. So essentially, I'm going to graph this right here as y equals the tangent of x plus the square root of 3. And I'm going to say, well, where are the y values less than 0? That's going to satisfy this inequality. So let's grab this real quick. And let's come down here and paste this in, put the solution out of the way. Essentially, if you go to this graph, again, y equals tangent of x plus square root of 3, if you want to type that into Desmos, you're going to see that you have these vertical asymptotes, and that's everywhere where this guy's undefined. Remember, it's undefined at pi over 2 plus pi n, where n is any integer. That's everywhere where cosine is going to have a value of 0. So this right here, if you look at it, this is going to be pi over 2. Then this guy right here, this would be 3 pi over 2. Then this right here would be 5 pi over 2. Then this right here would be 7 pi over 2. So on and so forth. I'm actually going to get rid of these because I think they're going to be in the way. So let me get rid of that. I'm just going to keep that one. So essentially, if you look at this, you have your vertical asymptote here, and you're trying to see where the y values are less than 0. Well, anything that's greater than pi over 2, it can't be pi over 2 itself. And then anything that's less than 2 pi over 3, right there, that's going to be where it is 0. That's an x-intercept. So this part of the graph right here is where it's going to work. That's where the y values are going to be less than 0. Again, if you take this pi over 2 and you add pi, you're going to get to the 3 pi over 2. Let me write this back in. So this is 3 pi over 2. And then if you take 2 pi over 3 and you add pi, so this is 5 pi over 3. Again, let me arrow to this so you can see this. This is 3 pi over 2. So basically, again, it's going to work. So right here, that's your 5 pi over 3. And then basically, if you follow this part of the graph right here, that's again where the y values are going to be less than 0. So you can keep adding pi to each part right here to get additional solutions. So this piece and this piece, so on and so forth. All right, let's take a look at problem 3. So here we have 2 cosine of, and then inside the parentheses, you have 2x minus pi over 6, and this is less than or equal to 1. So what I'm going to do for this problem is use a substitution technique. You can do this in different ways, but I find the substitution technique is easiest. So if you have something with a bunch of stuff going on inside, what I'm going to do is say we're going to let something like u, you could use w, whatever you want to do, be equal to this right here. So 2x minus pi over 6. So that's going to do a lot for us. It's going to make the problem a lot simpler. I'm just going to say we have 2 cosine of u is less than or equal to 1. So here, when we find solutions in terms of u, things are going to repeat every 2 pi. Okay, so that's a little bit easier to work with than to try to figure this out. If you look at this, you have this 2 right here that's multiplying x. When we look at the graph at the end, you're going to again see that that is changing your standard period for cosine. Normally it's 2 pi, but because you have the 2 that's multiplying the x there, now it's going to be pi. And again, I'll show you that later on. So let me just grab this real quick. Let me come to a fresh sheet. We're just going to solve this, and then we'll go back up in a moment. So all you have to do for this problem is isolate the cosine of u on one side. And to do that, I'm just going to divide both sides of the inequality by 2. Cancel this. And we'll say that the cosine of u is less than or equal to 1/2. Okay, let's go to the unit circle, and let's paste this in. So again, I would just ask the question, where is the cosine of u equal to 1/2. Now the period for this, or how often the solutions are going to repeat, is going to be 2 pi. So I would solve this from 0 to 2 pi and see what we get. So u would be equal to, where is the cosine value 1/2? Well, it's going to be at pi over 3. There's your cosine value of 1/2. And then also, cosine is positive in quadrant 4. So where do I have a pi over 3 reference angle? So that 5 pi over 3. Again, the cosine value is 1/2. So let me circle that as well. So let's put pi over 3. And then 5 pi over 3. Now, because this is a non-strict inequality, these will actually work as a solution. So you got to keep that in mind. So where's the cosine value less than 1/2? We know where it's equal to 1/2. If I look between these guys, you'll notice that the cosine value is actually greater than 1/2. You have square root of 2 over 2, square root of 3 over 2. You have 1, square root of 3 over 2, square root of 2 over 2. So this is not going to work. What you're going to want is this part right here. So basically, between pi over 3 and your 5 pi over 3, that's what you want to put down as your solution. Now again, this is in terms of u. Let me get rid of this. Just keep in mind that these work. And I'm going to write this out. So we're going to say u, so not x yet, but u is greater than or equal to, let's start with pi over 3. So pi over 3. Again, the period here, because it's in terms of u, this is going to be 2 pi, so 2 pi n, where n is any integer. And less than or equal to, let's go 5 pi over 3. So 5 pi over 3. And again, plus 2 pi n, where n is any integer. Now let me go ahead and grab this real quick, and let's come back up here and paste this in. All right, so because we let u be equal to this, what we're going to do is make another substitution here. So basically, let me say that we have 2x minus pi over 6. So that's going to be in the middle. And this is greater than or equal to this pi over 3 plus 2 pi n. And it's less than or equal to 5 pi over 3 plus 2 pi n. So now all we have to do is solve this for x, and we're good to go. So basically, what I would do first is add pi over 6 to each part. So we're going to add pi over 6 to each part. So let's do that like that. So this is going to cancel. And essentially, if I do pi over 3 plus pi over 6, let's multiply this by 2 over 2. This would be 2 pi plus pi over the common denominator of 6. So that would be 3 pi over 6. 3 divided by 3 is 1, and 6 divided by 3 is going to be 2. So this would end up being pi over 2. So let me get rid of this, and I'm just going to rewrite it on another line so nobody gets lost. So this right here, if we add, we would get pi over 2, and then plus your 2 pi n. And this is less than or equal to. This is canceled, so let me put 2x, which is less than or equal to. So now you've got to do 5 pi over 3. I need a common denominator, so let me multiply this by 2 over 2. So that'd be 10 pi over 6. So let's say this is 10 pi over 6. And then basically plus your pi over 6. So 10 pi plus pi would be 11 pi. So this would be 11 pi over 6. So 11 pi over 6. And then basically plus 2 pi n. And now I just want x by itself. So I'm multiplying here by 2. So what you need to do is divide each part by 2. A good way to do this, because you have fractions involved, is just to multiply everything by 1/2. And let me show that so nobody gets lost. So let me come down here and say you're going to have 1/2 times pi over 2 plus 2 pi n times 1/2 less than or equal to 1/2 times 2x, which is less than or equal to 11 pi over 6 times 1/2 plus 2 pi n times 1/2. Maybe that n could be a little bit better there. Okay, let me grab this real quick and slide it over so it fits. 1/2 times pi over 2, that's going to be pi over 4. And then plus, the 2's would cancel. So notice that you get pi n here. Remember when I first introduced the problem, I said the period would be pi. So now you're seeing you get pi n. And then we have this is less than or equal to. The 2's would cancel. So your x, which is less than or equal to. This here would end up being 11 pi over 6 times 2 is 12. And then plus, again, the 2's would cancel. So you're going to have your pi n, where n is an integer. So this is one way to get the solution. There's obviously other ways to do it, but I think this is the easiest way to do it, especially if you're first starting out. So let's go ahead and grab this real quick. I want to quickly come back up and remind you what the original problem was. What I'm going to end up doing is graphing this by subtracting 1 away from each side. And we're going to look for where the y values are less than or equal to 0. So here's our little graph. Let me go ahead and paste this in. Put that right there. Again, this 2 that's multiplying this x here, that's creating a period that is pi, right? Remember, if you have the standard period of 2 pi, you're going to divide by this guy that's multiplying x here. So 2 pi divided by 2 gives you pi. So that's where that period's coming from. So when we look at the x-intercepts, or where this guy is 0, you'll see that you have a pi over 4. So that's going to be right here. And then you have 11 pi over 12. So that's going to be right here. So where is it less than or equal to 0? Well, these would be included because, again, you have a non-strict inequality, and then all of this right here. So this right here is where we're less than or equal to 0. So this whole thing. So that's those guys right there. And again, you can add pi to each part and get additional solutions. So pi over 4, if you added pi to that, you add 4 pi over 4, that would give me this 5 pi over 4. 11 pi over 12, if I added pi to that, that's 12 pi over 12. And so that would be 23 pi over 12. So that's this right here. And again, anywhere between that would be less than 0. So there's your solution there. And again, you can keep doing this to get this part and this part. Anywhere where the y values are going to be less than or equal to 0, you would satisfy that inequality. All right, for problem 4, we have negative 3 plus 2/5 sine of 2x minus 5 pi over 6, which is less than negative 16/5. All right, let me slide down here just a little bit. The idea, again, just like in the last problem, I'm going to let something like u be equal to this inside part right here. It's just going to make it a lot easier to solve. So 2x minus 5 pi over 6. And then you could say this is negative 3 plus 2/5. And then sine of u is less than negative 16/5. So let's solve this in terms of u. And then basically we'll come back and substitute like we did in the last problem. Okay, let's paste this in on a new sheet. Essentially, I want to isolate the sine of u on one side and have a number on the other. So let's go ahead and add 3 to both sides of the inequality. So you could write 3 as 15 over 5, just so that you would have a common denominator. And basically, this would cancel over here. You would have 2/5, and then sine of u is less than negative 16 plus 15. That's going to be negative 1. So this right here would be negative 1/5. Now what I would do, because I have 2/5 that's multiplying the sine of u, I would go ahead and multiply both sides by 5/2, so the reciprocal there. And let's see what that does. So basically, these are all going to cancel. So you're just going to have a 1 there. So 1 times the sine of u is just the sine of u. So the sine of u is less than. The 5's would cancel. So this is negative 1/2. Okay, let's come down here and paste this in. So again, you would ask the question, where is the sine of u equal to negative 1/2? And because in terms of this u right now, the period is 2 pi, so I can say I'm just going to solve this over the interval from 0 to 2 pi and see what that produces for me. So I want to look in quadrants 3 and 4, where sine is negative, and I want a reference angle of pi over 6. So that's going to be 7 pi over 6, there's your sine value of negative 1/2, and then 11 pi over 6, there's your sine value of negative 1/2. Okay, so let's go ahead and say that we're going to look between 7 pi over 6 and 11 pi over 6 and see, are the sine values less than negative 1/2? Yes. You can see that basically this is negative square root of 2 over 2, negative square root of 3 over 2, negative 1, negative square root of 3 over 2, negative square root of 2 over 2. So basically this right here is what we want. So this right here is what we want. We don't want values on the other part because, again, that's where you would be actually greater than negative 1/2 for the sine values. So to write our solution, we're going to say that u is strictly greater than. We're going to have this 7 pi over 6. And again, things are going to repeat every 2 pi here. So I'm going to put plus 2 pi n. And less than, we're going to go 11 pi over 6. So 11 pi over 6. And then plus 2 pi n. And let's go ahead and paste this in here. So again, u is equal to this. So I'm just going to plug this in here for u. So we're going to say that we have 2x minus 5 pi over 6 is greater than. We have 7 pi over 6 plus 2 pi n. And less than, we have 11 pi over 6 plus 2 pi n. And let me come down here to a little fresh sheet. Just like in the last problem, you need to isolate x in the middle. So I'm going to add 5 pi over 6 to each part here. And let's see what that does. So add 5 pi over 6. So essentially here you already have a common denominator. If you did 7 pi over 6 plus 5 pi over 6, that would give you 12 pi, which is coming from 7 pi plus 5 pi over 6, which is going to be equal to 2 pi. So this right here on the left is 2 pi. And then plus, don't forget this part right here, so 2 pi n. Then this is less than, this would cancel, your 2x, which is less than, you have your 11 pi over 6 plus 5 pi over 6. So 11 pi plus 5 pi is going to be 16 pi. So this right here would be 16 pi over 6. And each here is divisible by 2. 16 divided by 2 is 8. 6 divided by 2 is 3. So this ends up becoming 8 pi over 3. So 8 pi over 3. And then plus, don't forget your 2 pi n. All right, the next step, again, if you want x by itself, since you have 2 that's multiplying x, you could divide everything by 2, or you can multiply everything by a half, which I think is a little bit easier because you have a fraction involved. So let's go through and say we have 2 pi times 1/2 plus 2 pi n times 1/2, which is less than 2x times 1/2. Let me actually do this in a different order. So 1/2 times 2x like that, which is less than, you have your 8 pi over 3 times 1/2. And then plus, let me slide this over so it fits, you have your 2 pi n times 1/2. All right, so let's go through and say the 2's would cancel, so you have pi. And then plus these 2's would cancel, so you have pi n. So this is going to be less than, the 2's would cancel, so this is x, which is less than, so 8 divided by 2 is 4. So this is 4 pi over 3. And then plus the 2's here would cancel, so you get pi n. So that is your solution in terms of x. So x is greater than pi plus pi n, and less than 4 pi over 3 plus pi n. Let me grab this real quick. So coming back to the original inequality, when I graph it, it's going to be cleaned up a little bit. I just want you to remember this was a less than. So we're going to be looking for y values that are less than 0. All right, let's look at the graph. Again, we just cleaned this up a little bit, and we're looking for where the y values are less than 0. Now, on the practice test, I did give a different answer, but I'm going to explain where that's coming from and why it doesn't matter. So first off, you'll notice that you have this plus pi n and plus pi n. Again, I want you to know that that's coming from this 2 that is multiplying this x here. Again, the standard period, if you had y equals the sine of x, that's 2 pi. But if you have this 2x here, this 2 that's multiplying x, you're taking your standard period of 2 pi, you're dividing by 2, and you're getting pi for the period. So that's why this guy right here is plus pi n and plus pi n. Now, in terms of looking at the x-intercepts, we have these right here that we can start with. So we have pi. So basically, that's where this guy is going to be 0 in terms of the y value, and then 4 pi over 3. So where is it less than 0? Well, between those guys. So between these guys, so between pi and 4 pi over 3. So you can write your solution like this. It works just fine. Again, if you added pi to pi, you would get to 2 pi. If you added pi to 4 pi over 3, you're adding 3 pi over 3. So that would give you this 7 pi over 3 right here. And again, if you go between those guys, you're going to have y values that are less than 0. So you can get this piece, and of course this piece, and so on and so forth. Now, the way I wrote the solution, I actually used this one and this one to start things off. And I said, okay, between 0 and your pi over 3. So if you started with pi and you subtracted away pi, you would have 0. If you started with 4 pi over 3 and you subtracted away pi, or 3 pi over 3, you would have pi over 3. And if you use those guys to write it, what you could do is say that x is greater than, you could go 0 plus pi n, which is just pi n, and less than, you can go pi over 3 plus pi n. So another way to write it, this way is fine, this way is fine, whatever you want to do. I'll probably just stick with this one because that's how I wrote it on the practice test. So let's just go ahead and say that x is greater than pi n and less than pi over 3 plus pi n, where n is any integer. All right, let's take a look at problem 5. So here we have 1 minus the cosine of x is greater than the sine of x. So for this problem, I'm going to use the test point approach. So you'll remember this is what we used when we solved quadratic inequalities, rational inequalities. It's basically the same concept. I would write this as 1 minus the cosine of x, subtract the sine of x away from each side. So minus the sine of x, we're going to say, where is that greater than 0? Let me go ahead and grab this real quick, comment down here. And essentially, you're going to replace this inequality symbol with equals. You're just going to solve that related equation. So 1 minus the cosine of x, then minus the sine of x, where's that equal to 0? Well, because we have cosine of x and sine of x, let me add the sine of x to each side. So let me say we have 1 minus the cosine of x is equal to the sine of x. And essentially, I'm going to square both sides. So you're going to have 1 minus the cosine of x squared is equal to sine squared x. Here's where you have to be careful. When you square both sides of an equation, you have to check your solutions. There's a possibility of extraneous solutions, so you have to be real careful here. So let me slide down. We're going to come back up and check in a moment. This you have to expand. So it's 1 squared, which is 1, minus 2 times this guy. So it's just minus 2 cosine of x, and then plus this last guy squared. So cosine squared x. And this equals, instead of sine squared x, I'm going to rewrite this. Remember, you can put that as 1 minus cosine squared x, and that's just coming from sine squared x plus cosine squared x is equal to 1. If you subtract cosine squared x away from each side, you get the identity sine squared x is equal to 1. Let me go ahead and write it. So 1 minus the cosine squared x. And so I'm just plugging in for sine squared x, this 1 minus cosine squared x. Okay, so now that we have this set up, I'm going to subtract 1 away from each side of the equation. That cancels. And then basically I'm going to add cosine squared x to both sides of the equation. So that cancels. This is 0 on the right. Let's say cosine squared x plus cosine squared x is 2 cosine squared x, and then minus 2 cosine of x, and this equals 0. So I'm going to solve this using factoring. I'm going to pull out a 2 cosine of x from each part. So here you would just have the cosine of x, and then minus here you would just have 1, and this equals 0. So what I'm going to do is solve 2 cosine of x is equal to 0, and then or cosine of x minus 1 is equal to 0. So for this one, you would divide both sides by 2. So you're just going to solve cosine of x equals 0. For this one, you would add 1 to both sides. So you're going to see where the cosine of x is equal to 1. Now, in terms of this guy right here, your period, if you were solving this equation, or if you go back to your original equation that you set up, the period's going to be 2 pi. So solutions will repeat every 2 pi. So let me go ahead and grab this real quick. And again, we're going to come to the unit circle, and we're going to think about where the cosine of x is equal to 0. Again, I'm going to solve this from 0 to 2 pi for right now. And so x would be equal to, let's go ahead and say, where's the cosine of x equal to 0? Well, that's going to be at pi over 2, and then also 3 pi over 2. So let me write those in. So you can have pi over 2, and then 3 pi over 2. Now, 3 pi over 2 is going to be an extraneous solution, but I'll show you that in a moment. And then when we think about where the cosine of x is equal to 1, well, that's going to be right here at 0. So there's your cosine value of 1. So let's go ahead and put that down as 0. Okay, let me grab this real quick, and let me come back here and paste this in. So essentially what we're going to do is figure out which solutions work, and you do that by plugging in. We know that the cosine of pi over 2 and the cosine of 3 pi over 2 is 0. So in each case, you would get 1 on the left. On the right, it's going to change. So the sine of pi over 2 is 1, so this works. But the sine of 3 pi over 2 is negative 1, so that wouldn't work. So this one right here, you can just mark it out. Now this one right here with 0, it's going to work. So the cosine of 0 is 1, so 1 minus 1 is 0. And the sine of 0 is 0, so this one works as well. Okay, so basically get rid of this. And essentially, you're using these guys to split up the number line. So you have 0 and pi over 2. Let me grab this real quick. And I want to come back up. We're going to see this in a moment. I've already written it into the table. So 1 minus cosine of x minus sine of x is greater than 0. Let me come down and basically let me paste this back in here. And let me get rid of all of this. And I'm just going to show you the intervals we're going to set up here. So basically, these are the critical values. So you're going to look at 0 and pi over 2. So you're just going to have an interval between 0 and pi over 2 and an interval between pi over 2 and 2 pi. So again, I've already set everything up for us. We have 1 minus the cosine of x minus the sine of x. Where's that greater than 0? So you're just going to pick something in each interval, plug it into your calculator, and see if it's positive or negative. If it's positive, it's going to satisfy the inequality. If it's negative, then it's not. So between 0 and pi over 2, I'm going to pick pi over 3. Plug that in. You're going to get about negative 0.37. Again, I don't care what the value is. I just want to know if it's positive or negative. Because it's negative, it's not going to work. Then in this interval between pi over 2 and 2 pi, I'm going to pick 2 pi over 3. You plug that in, you get about 0.63. So this is going to work. So if we want to write our solution, you can come back and say, okay, well, between pi over 2 and 2 pi, that is where it's going to work. So let's put that like that. And so essentially, because it's a strict inequality, we're not going to include either of those. And because the period is 2 pi, again, if you go back to this form here, if I graph y equals 1 minus the cosine of x minus the sine of x, the period of this is 2 pi, the period of this is 2 pi, so the least common multiple is 2 pi, so I know things repeat every 2 pi. Okay, so coming back down, let's say that x is greater than pi over 2 plus, again, the 2 pi n, where n is any integer. Let's make that better. And less than, we're going to go 2 pi plus 2 pi n, where n is any integer. So let's go ahead and grab this real quick. Again, when I graph this, I'm going to be looking for where the y values are greater than 0. Okay, let's come down to the graph. I'm going to paste in my solution. So again, where is it equal to 0? Well, we found our pi over 2. We have pi over 2. And we also found at 2 pi, it's going to be equal to 0. So if you look between those guys, we're going to have where the y values are greater than 0. That's what we're looking for. So this right here, this would be a solution. So between pi over 2 and 2 pi. Now again, if you want to add 2 pi to each part, you take pi over 2 and you add 4 pi over 2, that's getting a common denominator, you're going to get to this 5 pi over 2. If you take 2 pi and you add 2 pi, you're going to get to 4 pi. And again, between those values, you'd have y values that are greater than 0. And so again, you would satisfy that inequality. So x here is greater than pi over 2 plus 2 pi n and less than 2 pi plus 2 pi n, where n is any integer. All right, let's take a look at problem 6. So here we have negative cosecant of x plus cotangent of x is greater than or equal to negative 1. So again, for this type of problem, we're going to go back to the test point method. Let me write negative cosecant of x plus cotangent of x. Let me add 1 to both sides. So plus 1, where is this greater than or equal to 0? So that's what we're trying to figure out. So let me go ahead and grab this real quick. And let me come down here. Now I'm just going to warn you in advance, this problem is a little bit tricky because when you think about the cosecant of x and the cotangent of x, you have an issue where it's going to be undefined at certain points. And actually, when you look at the graph, it's going to be a little bit complicated. So I'm going to really take my time and go slow. So first off, if you look at something like y equals negative cosecant of x, plus cotangent of x plus 1, if I asked you for the domain of that, what would it be? Remember that the cosecant of x, by definition, so the cosecant of x is 1 over the sine of x. So this would be undefined anywhere where the sine of x is 0. So that's going to be at 0, pi, 2 pi, 3 pi, so on and so forth. So basically pi n, where n is any integer. Then if you look at the cotangent of x, this is going to be the cosine of x over the sine of x. So again, anywhere where the sine of x is 0. So pi n, where n is any integer. So if I wanted to write the domain for this, so the domain, I would say it's the set of all x such that x is not equal to pi n, where n is any integer. So anything other than that, you'll be good to go for plugging in for x. Let me erase this. We're going to bring this back up later on when we look at the graph. Let's just think about how we could solve this. I'm just going to first replace this with equals. So negative cosecant of x plus cotangent of x plus 1 is equal to 0. The goal here would be to isolate one of these, square both sides, and use an identity. So I'm just going to add cosecant of x to each side of the equation. And so this would cancel. You're going to get that the cotangent of x plus 1 is equal to the cosecant of x. Again, you have to be careful when you square both sides of an equation because you can get extraneous solutions. And in this case, we will. So let's go ahead and square both sides. So cotangent of x plus 1 squared is equal to cosecant squared x. So this right here, if you expand it, you get cotangent squared x. So just squaring the first guy plus 2 times this guy times this guy. So 2 cotangent of x. And then plus this last guy here, 1 squared, which is 1. And this equals cosecant squared x. Okay, I'm just going to erase things as I go. I'm going to move this up here. I want you to recall that when we studied the Pythagorean identities, we had the identity that the cosecant squared x was equal to 1 plus cotangent squared x. So again, if these guys are a match, you can plug in this right here for this right here. So I'm going to say that I have cotangent squared x plus 2 cotangent of x plus 1 is equal to 1 plus cotangent squared x. And essentially, I'm going to subtract 1 away from each side, so that's going to cancel and that's going to cancel. And I'm going to subtract cotangent squared x away from each side of the equation. So that's going to cancel. The right side is 0, and so this is going to cancel. You get 2 cotangent of x is equal to 0. Divide both sides by 2. This cancels, and you're going to get cotangent of x is equal to 0. So let's think about that for a moment. Let's grab this real quick. Let's come down here and paste this in. Again, if I think about the cotangent of x, this is the cosine of x over the sine of x. So where would that be equal to 0? Well, it's where the cosine value is 0 and the sine value is not 0. So you're going to see that that's going to be right here at pi over 2, and then that's also going to be right here at 3 pi over 2. I'm going to go ahead and solve this over the interval from 0 to 2 pi, because again, if I thought about y equals negative cosecant of x plus cotangent of x plus 1, things are going to repeat there every 2 pi, right? Because the period for this is 2 pi, and the period for this is pi. So the least common multiple between 2 pi and pi would be 2 pi. So I know things are going to repeat every 2 pi. So let me come back down and just say that the solutions or the proposed solutions, because one of these is not going to work, from 0 to 2 pi, basically your x is going to be pi over 2 and then 3 pi over 2. And let's come back up here. So let me paste this in, and let me just show you that one of these is not going to work. So the cotangent of pi over 2 and the 3 pi over 2, in each case, that's going to be 0. So the left side is always going to be 1. On the right, though, the cosecant of pi over 2 is going to be positive 1. So this one does work. We're okay. But the cosecant of 3 pi over 2 is a negative 1. So that's negative 1, so that would be false if you do it that way. And so basically this doesn't work. So let me get rid of this, and let's get rid of this. So essentially, when you split up the number line, you're going to be using pi over 2 as a critical value. But again, you have to also consider where this guy is undefined, right, when we work with this problem. So you have your cosecant of x involved and your cotangent of x involved. And we already said that x cannot be pi n where n is any integer. So we would say 0 and pi there, those are going to have to be excluded because in each case, you're going to get division by 0, which is undefined. So that's going to give me an interval between 0 and pi over 2, and then between pi over 2 and pi, and then between pi and 2 pi. So basically, I'm just going to set that up and test. Again, I've already set the table up for us. So I have negative cosecant of x plus cotangent of x plus 1. Where is that greater than or equal to 0? So we already know it's equal to 0 at pi over 2. But we're trying to figure out where is it greater than 0. So I'm just going to pick something in each interval and test. So in this first interval between 0 and pi over 2, I'm picking pi over 6. Plug that in, you get about 0.73. So this is positive, so it's going to work. Then here, between pi over 2 and pi, if you work in this interval, let's say we pick 5 pi over 6, we get about negative 2.73. So this is negative, so it's not going to work. Then in the interval between pi and 2 pi, well, basically we're picking 7 pi over 6. You plug that in, you get about 4.73. So this is positive, so this is going to work. Now the solution here is a little bit complicated to put together. Okay, so coming back to the unit circle, let's think about our solution. So we know that things work in this interval right here. And for right now, I'm not going to include anything. So I'm just going to say between 0 and pi over 2. Pi over 2 will be included, but I'll get to that in a moment. And then things are going to work between pi and 2 pi. So basically right there. So you don't want to include this right here. It would be undefined at 0, 2 pi, 4 pi, 6 pi, so on and so forth. And you don't want to include this right here. It would be undefined at pi, 3 pi, 5 pi, 7 pi, so on and so forth. But you do want to include this one right here because that's what makes it 0. And this is a non-strict inequality. So putting the solution together is a little bit tedious. Essentially, you're going to say that x is strictly greater than. You're going to start with 0. So you're going to go 0 plus 2 pi n, because again, things are going to repeat every 2 pi here, but 0 plus 2 pi n is just 2 pi n. So I'm going to put 2 pi n. So that's 0, 2 pi, 4 pi, so on and so forth. Then we'll say, and it's less than this pi over 2, but I want to include that, so let me put less than or equal to, so the pi over 2, and then plus 2 pi n, where n is an integer. Then you're going to use the keyword or, so that's how we're going to join this here. And you're going to think about this part right here. So maybe I can do that in a different color, so it's a little bit more obvious what we're doing. Again, we're breaking this up into 2 separate parts. So this right here, so I'm going to say that x here is strictly greater than, you don't want to include pi, so you're going to say pi plus 2 pi n, and less than, this would be 2 pi, so 2 pi plus 2 pi n. Okay, let's take a look at the graph. So again, we want to know where negative cosecant of x plus cotangent of x plus 1, where's that greater than or equal to 0? Now, before I move forward with this, I want to explain some differences between the graph I'm giving you here and what you might see on an online graphing calculator like Desmos. We know, because we thought about it earlier, that the domain for this guy right here is going to be the set of all x such that x is not equal to pi n, where n is any integer. So again, if you plugged in something like 0, pi, 2 pi, 3 pi, you're going to get undefined here. Now, if you want to split this up into different cases, you can say that at 0, 2 pi, 4 pi, 6 pi, so I'm going to call that 2 pi n. So at this case right here, you're going to actually get a hole in the graph. So that's why you see these holes here. So here, 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 here. So let's just go with this. This is 0, 2 pi, 4 pi, 6 pi. Now, if you go to Desmos and you mouse over an x value of 0, you're going to get this right here, and it'll actually give you a hole, and it'll say it's undefined. And that's because they're actually plugging in 0, and so that is undefined. But if you go over to what looks like 2 pi, they're going to approximate that. Let's just say they use about 6.28, and you can actually plug that in there because it's not actually 2 pi. You will not get undefined. You will get something that's very, very close to 1. So as you get closer and closer to 2 pi, without touching it, you're going to get closer and closer to a y value of 1, but you'll never touch it. So that's something that would come up when we talk about limits, and we'll get to that later on in the course. But for right now, you have to know that at 2 pi or 4 pi or 0 or 6 pi or something like that, basically 2 pi n, you're going to get a hole in the graph because this guy is going to approach a y value of 1, but it won't touch it. Now, the other scenario occurs at pi, and then you have 3 pi, and then 5 pi, so on and so forth. So let's say that's pi plus 2 pi n. Well, basically there, you're getting a vertical asymptote. So let me write v period a period for vertical asymptote. Basically what's happening is as you approach pi or 3 pi or 5 pi, what's happening is your y values are approaching positive or negative infinity, just depending on which direction you're approaching it from. So basically that's why you're getting a vertical asymptote there. Okay, so now that we understand the graph and why it might be different from what you're going to see, let's think about our solution here. Basically, we're looking for, again, where the y values are going to be greater than or equal to 0. So let me start right here. This right here was 2 pi n. So that's 0, 2 pi, 4 pi, so 0, 2 pi, 4 pi, so on and so forth. So x is greater than 2 pi n and less than or equal to pi over 2 plus 2 pi n. So let's take this piece right here. So this piece right here, and that's going to include this pi over 2 because that's where we're greater than or equal to 0. So you have this part right here. And again, if you're adding 2 pi to each part, well, basically, again, 0 plus 2 pi is 2 pi, and pi over 2 plus 2 pi, that's going to be 5 pi over 2. So you're going to get this piece right here. And if you keep doing that, you're going to get this piece right here, and so on and so forth. When we think about the other part, we have or x is greater than pi plus 2 pi n and less than 2 pi plus 2 pi n. So we're thinking about this guy right here is going to be pi. So let me write that in. So this guy right here is going to be pi. That's your vertical asymptote. So we know we can't actually plug in pi. Well, here we're saying that x is greater than pi, so that's going to be up here, and less than 2 pi. So that's going to be this piece right here. So let me do this in a green color. So this piece right here, well, of course, we're going to be greater than 0 there. So that's going to be right here. But we're going to have to stop right there at that 2 pi because we're undefined. So that's where it's not going to work. Again, because at 2 pi, 4 pi, 6 pi, 8 pi, it's not going to work. So basically, let me draw this in like this. So this piece like this. And basically, you could do this piece right here like this if you wanted to. So you can keep going like that. So basically, you see the solution and how it repeats. So this is one way you could write it. You could say x is greater than 2 pi n and less than or equal to pi over 2 plus 2 pi n. Again, because this is included and this is excluded. Or x is greater than pi plus 2 pi n and less than 2 pi plus 2 pi n, where n is any integer. And again, that's coming from the fact that things like pi and 2 pi are going to be excluded because that's where you're undefined. All right, let's take a look at problem 7 now. So we have the cosine of 2x plus 2 is greater than negative 3 cosine of x. So let me add 3 cosine of x to both sides. And I'm going to solve cosine of 2x plus 3 cosine of x. And then plus 2 is greater than 0. So let me grab this real quick. And we'll just come down here. Again, I'm just going to solve the related equation, get some critical values, and then we're just going to set up some intervals and test. So I'm going to go cosine of 2x plus 3 cosine of x plus 2 is equal to 0. Now, again, when you think about the period here, it's going to be 2 pi. The period for this guy right here, this part, is going to be pi. Because if you think about y equals cosine of 2x, well, again, that 2 that's multiplying the x, that's going to speed things up. So it's 2 pi divided by 2, which gives you pi. Then when you look at this part here, and it doesn't matter if you think about it as 3 cosine of x or cosine of x, when you think about the period for that, it's going to be 2 pi. So this is just the standard 2 pi. And again, if you graph y equals cosine of 2x plus 3 cosine of x plus 2, which we're going to do in a moment, you'll see the period is 2 pi. So it's just the least common multiple of these two periods. So 2 pi and pi. So the LCM is going to be 2 pi. All right, so now that we know that, let's make a little substitution. So we know that the cosine of 2x, we have 3 different formulas we can use. Because there's a cosine of x here, I'm just going to say this is equal to 2 cosine squared x and then minus 1. So again, since this right here matches this right here, I'm just going to take this right here and plug it in for that right there. All right, so let's say we have 2 cosine squared x minus 1, and then plus 3 cosine of x plus 2, and this equals 0. All right, so we know that negative 1 plus 2 would be positive 1. So I'm just going to erase this and put this like this. And essentially all you need to do is factor the left side. We've factored this particular guy many times throughout this section, so I think a lot of you will know it off the top of your head. It's basically 2 cosine of x and then cosine of x. And again, because this is a +1 and this is a +3 here, well, basically it's just +1 here and +1 here. So the outer, if you want to check this, let's say it's +2 cosine of x, and then the inner is plus cosine of x. So of course, 2 cosine of x plus cosine of x, that's 3 cosine of x. So that's what I'm looking for. All right, so to solve this with the zero products property, I'm just going to say 2 cosine of x plus 1 is equal to 0. Subtract 1 away from each side. So you have 2 cosine of x is equal to -1. Divide both sides by 2. So we have cosine of x equals -1/2. Then you have or. For this one, you have cosine of x plus 1 equals 0. So that's going to be cosine of x. Let me make this s a little bit better. We'll say that's equal to, if I subtract 1 away from each side, it'll be -1. Okay, let me grab this real quick. Come down to the unit circle here. And basically, again, because when we established earlier that the period would be 2 pi, well, I'm just going to solve this over the interval 0 to 2 pi, like this, and basically see where the critical values are. So for cosine of x equals -1/2, we know cosine is negative in quadrants 2 and 3, and I'm looking for where I have a reference angle of pi over 3. So that's 2 pi over 3. There's your cosine value of -1/2. And then at 4 pi over 3, there's your cosine value of -1/2. Then you also have cosine of x equals -1. Well, that's just going to be right here at pi. So essentially, you're going to have an interval from 0 to 2 pi over 3, and then from 2 pi over 3 to pi, and then from pi to 4 pi over 3, and then from 4 pi over 3 to 2 pi. So I have everything set up already. So we have cosine of 2x plus 3 cosine of x plus 2 is greater than 0. So I'm just using this form here. If you want to make the substitution and write it the other way, that's up to you. It's the exact same thing. So basically, we see in each interval that I've already picked a little value and done a test. I'm just trying to figure out where it's greater than 0. So I want the positive guys only. So in this interval, if I plug in pi over 4, I get about 4.12. So this would work, right? Because it's greater than 0. And then in this interval, if I pick 3 pi over 4, I get about -0.12. So this is negative. It's not going to work. In this interval, if I pick 5 pi over 4, I get about -0.12. So again, it's negative. It's not going to work. And then in this interval, I'm going to pick 7 pi over 4. So again, I get about 4.12. So this is going to work. It's positive. So between 0 and 2 pi over 3, and then between 4 pi over 3 and 2 pi. So let's come back to the unit circle. Again, when you have a solution like this, it can be a little bit complicated. Let me put this like this. So this right here was an artificial boundary that we created because I solved over the interval from 0 to 2 pi. So really, there's nothing stopping me from doing it continuously like this. So if you want to put your solution together here, what I would do is say, let's just start with 4 pi over 3. So x is greater than 4 pi over 3. And then again, you go plus 2 pi n, where n is any integer. Maybe I could slide that down a little bit. And we'll say, and it's less than. Again, this is not 2 pi over 3. I'm starting here. So basically, if I rotate like this, I'm going to add 2 pi to this. So it's 2 pi over 3 plus, I'm going to go 6 pi over 3. That's me putting 2 pi in terms of having a common denominator. So basically, this is 8 pi over 3. So let's say this is 8 pi over 3 and then plus 2 pi n. Again, if you wanted to rotate clockwise here, so that would be 4 pi over 3 minus 6 pi over 3. So this right here, if I rotate it clockwise, let me show this. This right here, like that, that would be -2 pi over 3. So if you want, you could write the solution as x is greater than -2 pi over 3, and then plus 2 pi n. And I never leave enough room for this. Let me do it like that. And then basically, and it's less than, well, now if you're starting from -2 pi over 3 and you're swinging around here, so basically it would be less than this 2 pi over 3. So this is 2 pi over 3 and then plus 2 pi. And let me slide over a little bit so I can fit this in. So this is what I listed for the practice test answer. So I'll just go with this. When we get to the graph, I'll show you this one as well. So let's go ahead and grab this real quick. And let me come down here to the graph and just paste this in so we can look at this. Again, I'm graphing y equals the cosine of 2x plus 3 cosine of x plus 2. Again, the period is 2 pi because the period for this guy right here is going to be pi. The period for this guy right here is going to be 2 pi. So you want the least common multiple of those periods, and that's going to be 2 pi. So that's going to be the period for the whole thing. All right, so if we look at this answer here, so 4 pi over 3, let's find that. So that's right there. That's where this guy's going to be 0. And then 8 pi over 3, that's going to be right there. So that's where this guy is 0. Now that's not included because we have a strict inequality. We're trying to figure out where it's greater than 0. So basically, if you look at this piece right here, so greater than 4 pi over 3 and less than 8 pi over 3. So that's one way you can put the solution. And again, you could add 2 pi to each part. So 4 pi over 3 plus 2 pi, that's me adding 6 pi over 3, so that's going to be 10 pi over 3, and then 8 pi over 3 plus 6 pi over 3, that's going to be 14 pi over 3, that's going to be right there. And again, you can just go through and say, okay, well, the y values would be greater than 0 between those two guys. So that one there. And then let me show you the other one that I talked about. Remember, I said if you rotate clockwise, you get this negative 2 pi over 3. And I got that from taking the 4 pi over 3 and subtracting away 2 pi. So that's going to be right here. So that's down here. So it's negative 2 pi over 3. I know this up here kind of looks like it's over there, but this is in line with this. So this is your negative 2 pi over 3. And then we would go over here to 2 pi over 3. And again, that's where your y values are going to be greater than 0. So that right there. Let me just go back real quick. So this rotating this way clockwise, if I started here and said, well, it was greater than negative 2 pi over 3, and then I could swing around to 2 pi over 3, so it would be less than 2 pi over 3. So greater than negative 2 pi over 3 and less than 2 pi over 3. So that's where I'm getting those guys from. So again, coming back, you could have listed your solution that way. So you could say negative 2 pi over 3 plus 2 pi n is less than x, which is less than 2 pi over 3 plus 2 pi n, where n is any integer. But I'm just going to list it this way. This is what we did on the practice test. So let's say that x is greater than 4 pi over 3 plus 2 pi n and less than 8 pi over 3 plus 2 pi n, where n is any integer. All right, let's take a look at problem number 8. So here we have sine squared of 2x is greater than or equal to 3 cosine squared x. So what I'm going to do to start things off is just subtract 3 cosine squared x away from each side of the inequality. So let's write sine squared. I'm going to wrap this so of 2x like this, and then minus 3 cosine squared x. And of course, now this would be greater than or equal to 0. Again, all I did was subtract 3 cosine squared x away from each side of the inequality. So that gives me this form here. So let's come down here. I think we know the drill at this point. We're just going to replace this inequality symbol with equals. We're going to solve and then generate some intervals, and we're going to test. So here I'm just going to write sine squared of 2x. I'm going to change that in a moment. Then minus we have 3 cosine squared x. And I'm going to say, where is this equal to 0? Now, you've seen for most of these problems, we've solved over the interval from 0 to 2 pi. Not every problem. We had one with tangent. We also had one with stuff inside where we made a substitution. But generally speaking, the problems that we've seen, we've solved the equation from 0 to 2 pi. And then basically, we've gone through and set up the intervals, and then we test. In this particular case, we're going to solve from 0 to pi. Now, where are we getting that from? Essentially, we haven't really talked about this yet, but if you looked at the period of something like y equals sine squared of 2x, it's going to be pi over 2. Now, there's a little formula you can use. You can look it up online if you want. This doesn't come up too often, so I'm not going to spend a whole lot of time on where it comes from or anything like that. I'm just going to give it to you, and it's given to you in the practice test as well. So the period for this, whether you look at it as, let's say, y equals 3 cosine squared x, or if you just want to look at y equals cosine squared x, either way, the period for this is going to be pi. And again, you can pause the video, go on Desmos, and look at it. You'll be able to visually see that for each part here, the period that I'm giving you is correct. Now, when you want the period of the whole thing, let's say you graph y equals sine squared of 2x minus 3 cosine squared x, what is that going to be? Again, it's the least common multiple of these periods, so it's going to be pi. So that's why when I solve this equation, I'm going to solve it over the interval from 0 to pi, 0 being included, pi being excluded. All right, so what I'm going to do now is just make a little substitution. I think we all know that the sine of 2x, there's only one formula. It's basically going to be 2 sine of x cosine of x. Now, you have to be careful because you have this squared guy involved. So what I do to not make a mistake, I go ahead and rewrite this as the sine of 2x just being squared like that. So that's basically what this notation means. And then let me write minus 3 cosine squared x, and this equals 0. And again, this right here is going to match this right here. So all I'm going to do now is take this right here and plug it in for that right there. Let me slide down and get a little room going here. And let's go ahead and say that we're going to have this 2 sine of x and then cosine of x. And let me wrap this. This whole thing's going to be squared. So again, just plugging in there, the whole thing squared. Then minus, you have your 3 cosine squared x, and this equals 0. All right, now this is multiplication here. So in other words, if you had a times b times c, and this guy was squared, this is a squared times b squared times c squared. So that's a rule we learned a long time ago in algebra. So I'm just going to apply that here. So everything will be raised to the second power or squared. So you're going to have 2 squared times sine squared x times cosine squared x, and then minus 3 cosine squared x, and this equals 0. Obviously, 2 squared is 4, so you can just put that like that. You can drop the multiplication symbol. You don't really need it. You can keep it if you want. So basically, you're going to solve this with factoring. You'll notice that you have cosine squared x and cosine squared x. So you can just pull that out. So let's pull that out in front of some parentheses. You'll have cosine squared x times the quantity. So inside, you're going to have 4 sine squared x, and then minus 3, close that down, and this equals 0. All right, so using the zero products property, now we can say that cosine squared x is equal to 0, or we have 4 sine squared x minus 3 is equal to 0. Well, this one, by the square root property, if cosine squared x equals 0, then the cosine of x, you would say, is equal to plus or minus the square root of 0, but there is no plus or minus the square root of 0, it's just going to be 0. So you can change this into cosine of x just equals 0. Now moving on to the other one, 4 sine squared x minus 3 equals 0. Add 3 to both sides of the equation. This will go away, and let's say that this equals 3 here. And let's go ahead and divide both sides of the equation by 4. Let's cancel that away. And so basically, again, by the square root property, if sine squared x equals 3/4, then the sine of x, so the sine of x is equal to plus or minus the square root of 3/4. Let me move this up here. So this equals plus or minus the square root of 3/4. Of course, this would be plus or minus the square root of 3 over the square root of 4 is 2. All right, let me grab this real quick. Come down here to our unit circle. I think most of you can do this without it, but we'll just put it here for a visual aid. Again, we want to solve over the interval from 0, with that being included, to pi, again, because of the period of what we're working with. So I only need to solve over this because the solutions you'll see will repeat every pi. So for the cosine of x being equal to 0, again, just working in this interval, it's just going to be right here at pi over 2. You don't need to list the 3 pi over 2 because we just want to work in this interval. Then for the sine of x being equal to plus or minus the square root of 3 over 2, well, again, the square root of 3 over 2, if you look for that as a sine value, you have it right there at pi over 3, and then you're also going to have that right here at 2 pi over 3. Now, again, if you think about this in terms of how solutions repeat, if you look at a solution here, you're also going to have a solution here because you have square root of 3 over 2 here and negative square root of 3 over 2 here. And remember, it's plus or minus the square root of 3 over 2. So you can see that this is going to repeat every pi. So this right here would repeat every pi. So add pi, get there, add pi, you'll keep getting solutions. The other one, this 2 pi over 3, again, if you add pi, you're going to be at 5 pi over 3. So again, add pi, you get to another solution. Add pi, you get to another solution, so on and so forth. Again, this is negative square root of 3 over 2. This is positive square root of 3 over 2. But again, we want either positive or negative square root of 3 over 2. So we're good to go there. Then this one right here and this one right here, again, every pi. You can see your cosine value is 0 there as well. So add pi, add pi, add pi. You keep getting to solutions. All right, so thinking about the intervals you'll have between 0 and pi over 3, then between pi over 3 and pi over 2, between pi over 2 and 2 pi over 3, and then between 2 pi over 3 and pi. So that's all you really need to do. Let's go down to our little table. So I've already set it up. So I'm going to work with it in this form. So sine squared of 2x minus 3 cosine squared x. Where is that greater than 0? We don't care about where it's equal to 0 because we already know that. It's going to be at pi over 3, pi over 2, and 2 pi over 3. We've already established that. So basically looking for where it's greater than 0, we're going to plug in something in that interval and just test, and we'll look at what we get and see if it's positive, we'll accept it. If it's negative, we'll reject it. So I'm going to choose pi over 6 in this interval between 0 and pi over 3, and I get exactly negative 3/2. So this would be rejected, it's negative. And then in the interval between pi over 3 and pi over 2, I'm going to pick 5 pi over 12, which is going to be 75 degrees. And so I get about 0.05. I don't care what the value is, it's positive, so I'm going to accept that. Then in the interval between pi over 2 and 2 pi over 3, I'm going to pick 7 pi over 12, that's 105 degrees. And again, if I plug that in, I get about 0.05, so that's positive, so that's going to work. And then in this interval between 2 pi over 3 and pi, I'm going to pick 5 pi over 6. If I do that, I get exactly negative 3/2, so that's negative, it's not going to work. Now let's go back down, and let's think about this here. So you have between pi over 3 and pi over 2, so it works there. And then you have between pi over 2 and 2 pi over 3, so it works there. Now, would pi over 2 be included? Yes, this is a non-strict inequality. Would pi over 3 be included? Yes, this is a non-strict inequality. Would 2 pi over 3 be included? Yes, this is a non-strict inequality. So essentially, let me get rid of this circling here. I'm just going to do this like this as one continuous piece here. And again, if you added pi to each part, well, essentially, if you start with pi over 3, again, if you add pi, you're going to get to 4 pi over 3. And then if you took 2 pi over 3 and you added pi, you're going to get to 5 pi over 3. So this piece right here would work as well. And again, you could just continue in that pattern forever. Let me get rid of this and we'll write the solution out. I think it's pretty easy to do. So we're going to say that x is greater than or equal to, let's go pi over 3. So pi over 3, and then plus pi n. Again, the period of what we're working with is going to be pi. Let me put this back in here. We'll say and it's less than or equal to, we're going to go 2 pi over 3. So 2 pi over 3 and then plus pi n. All right, let me paste this solution in here. So again, you can go to Desmos and just type in y equals sine squared of 2x minus 3 cosine squared x. And we're trying to figure out where the y values are either equal to 0 or greater than 0. So basically, if I look at these x-intercepts here, let me just point them out. So we have this pi over 3 here, and then we have this 2 pi over 3 here. Now you'll notice that we also have this x-intercept of pi over 2. Now notice if I go between here, you're going to see that, and this is a little bit hard to make out, but basically everywhere here, starting from pi over 3 and going to 2 pi over 3, I either have a y value of 0 or something that's greater than 0, so this whole thing would work. So from pi over 3 to 2 pi over 3, that would basically all work, and including those end values. Now again, if you add pi to each part, you would get additional solutions. So if I said pi over 3 plus pi, that's adding 3 pi over 3, so that would be 4 pi over 3. If I took 2 pi over 3 plus pi, so plus 3 pi over 3, that's 5 pi over 3. And again, if you want to take that middle guy there, that x-intercept of pi over 2, well, if you add pi, that's going to be plus 2 pi over 2, so that's 3 pi over 2, so that guy right there. And again, everywhere starting from 4 pi over 3 and including that, going up to and including this 5 pi over 3, we're going to have a solution because the y value is either 0 or greater than 0. So basically, you can just keep doing that as much as you want. So you'd have a solution here, and so on and so forth. So let's go ahead and say that x is greater than or equal to pi over 3 plus pi n, and less than or equal to 2 pi over 3 plus pi n, where n is any integer. All right, let's take a look at problem 9. So here we have negative 2 cosecant of x sine of x is less than or equal to negative square root of 2 cosecant of x. All right, for this problem, you can solve it in quite a few different ways. The first thing I'm going to do is just add the square root of 2 cosecant of x to both sides of the inequality, just to get things started. So let me cancel this away and say this is 0. So I'm going to write negative 2 cosecant of x sine of x, and then plus the square root of 2 cosecant of x, and this is less than or equal to 0. So let me grab this real quick. Let's come down here and think about this. So basically, let's say we worked on something like y is equal to negative 2 cosecant of x sine of x plus the square root of 2 cosecant, let me make that c a little bit better, of x. And I asked you, what's the domain? So what am I allowed to plug in for x? Remember that the cosecant of x, so the cosecant of x, by definition, is 1 over the sine of x. So you're thinking about division by 0 here. So where would I have a sine value of 0? So that's at 0, pi, 2 pi, 3 pi. So basically pi n, where n is any integer. So if I ask you for the domain for this, you would say that the domain is the set of all x such that x is not equal to pi n, where n is any integer. So let me erase this. We'll bring this back up when we need it. How do I solve this inequality here? Again, I'm just going to solve the related equation to get things started. So let's say negative 2 cosecant of x sine of x plus the square root of 2 cosecant of x, and let's say this equals 0. So again, a lot of you are going to notice that the cosecant of x times the sine of x, that's going to be 1. So as long as you're not plugging in something to where this is undefined, this is going to be 1. This is going to be 1 over the sine of x times the sine of x. So as long as your sine value is not 0, you're basically good to go. So this would cancel, and you're going to get 1. So you could replace this with 1 and say negative 2 plus square root of 2 cosecant of x and figure out where is that equal to 0. So you can do that if you want. Basically, what I'm going to do is use a different approach. So I'm going to actually factor this. So I'm going to change this form over. Instead of negative 2, let me write this as negative square root of 2 times the square root of 2. So basically, if you multiply that together, you get negative 2. And then I'm going to pull out square root of 2 cosecant of x. What's going to happen is that's basically going to go away. You're going to have a no solution, and you'll have something in terms of sine that we can go to the unit circle and just solve really quickly. Okay, so let me say we pull out the square root of 2 cosecant of x, and then inside you'd have negative square root of 2 sine of x, and then plus, pull this out, you'd have 1, close it down, and this is 0. Okay, so this right here, if you do square root of 2 cosecant of x is equal to 0, divide both sides by the square root of 2, and you just get the cosecant of x equals 0, which has no solution. So that has no solution. Then over here, basically you're going to work on this part. So let me slide down a little bit. You have the negative of the square root of 2 sine of x plus 1 equals 0. Subtract 1 away from each side. You'd have this is equal to negative 1. Divide both sides by negative square root of 2. Let me just erase it from over here. Negative over negative is positive, and if you rationalize the denominator, you're going to get sine of x is equal to the square root of 2 over 2. Okay, let me grab this real quick. Keep in mind where this guy is also undefined, so we're going to need that. So the solutions here are going to repeat every 2 pi. So let me solve this over the interval from 0 to 2 pi, like this. So x would be equal to, again, square root of 2 over 2. Sine is positive in quadrants 1 and 2. So I want pi over 4. There's your sine value of square root of 2 over 2. And then also where I have a pi over 4 reference angle in quadrant 2. So 3 pi over 4, sine value of square root of 2 over 2. So let's put x equals, we're going to put pi over 4 and then 3 pi over 4. Now, when you set up critical values, you also have to go with where the guy is going to be undefined. Remember, the cosecant of x is undefined where the sine value is 0. So that's going to be right here at 0 and then right here at pi. So this will give us quite a few intervals to set up. I have everything ready on our table on the next page. Let me just show you what's going on here. So between 0 and pi over 4, and then between pi over 4 and 3 pi over 4, between 3 pi over 4 and pi, and then between pi and 2 pi. Okay, so everything's set up. So we have negative 2 cosecant of x sine of x plus the square root of 2 cosecant of x. Where is that less than or equal to 0? We know it's going to be equal to 0 at the pi over 4 and 3 pi over 4. So those will be included when we set up our solution. But basically right now we need to figure out, well, where is it less than 0? If I go into this interval here and I choose pi over 6, I get about 0.83. So that's not less than 0. That's positive. So let's get rid of that. If I go into this interval and I pick 2 pi over 3, I get about negative 0.37. So that's negative. So this is going to work. And then if I go into this interval here and I pick 5 pi over 6, again, I get about 0.83. So this is not going to work. It's positive. And if I go into this interval here, I pick 4 pi over 3, and I get about negative 3.63. So this is negative, so this is going to work. All right, so putting this solution together, you've got between pi over 4 and 3 pi over 4, and then between pi and 2 pi. So coming back, you have between pi over 4 and 3 pi over 4, and then you have between pi and 2 pi. So you've got to think about what's going to be included and what's not going to be included. Right here, this would be included because this is going to make that inequality true, because pi over 4 and 3 pi over 4, you're going to get 0. So basically, that would be a true statement. But 0, 2 pi, 4 pi, something like that, that's not going to work because it's undefined there. So you cannot put 2 pi in, and you cannot put pi in. Same thing. So pi, 3 pi, 5 pi, basically pi in where n is any integer. You can't include those. You're going to see you have vertical asymptotes when we get to the graph. So let's write that x is greater than or equal to, let's go pi over 4 plus 2 pi n, and it's less than or equal to, let's go 3 pi over 4 plus 2 pi n. Then I'm going to go or, I'm going to take this part right here. So x is greater than, we're going to have pi plus 2 pi n, and it's less than, this right here would be 2 pi. So let's write that as 2 pi plus 2 pi n. Again, these are not included because at pi and 2 pi, it's undefined. So you cannot include that. These are included because at pi over 4 and 3 pi over 4, I would get a value of 0, and 0 is equal to 0, so that would work. Let me go ahead and grab this. Okay, I have everything set up for us. Let me paste this in. Let me get rid of this highlighting. We don't need that. And it's a little bit hard to read, but basically you can go to Desmos and just make your own graph if you want to be able to see it more clearly. Essentially, when we look at this, we're looking for the y values where it's going to be 0 or less. So less than or equal to 0. If you go to pi over 4, so that's going to be right here, that's where it's equal to 0. If you go to 3 pi over 4, again, that's where it's equal to 0. So right here, this is all included. So from pi over 4 to 3 pi over 4. Again, if you add 2 pi to each part there, so pi over 4 plus, let's go 8 pi over 4, that would give you 9 pi over 4. If you go 3 pi over 4 plus 2 pi, that's going to be 3 pi over 4 plus 8 pi over 4, that's 11 pi over 4. So again, that's this piece right here. You can keep getting this piece again and again. So this right here, and then this right here, so on and so forth. So that's all of those. Now the other part that you need, because again, this is less than or equal to 0, you need these parts right here. So how do you get that? Well, that's where we come in for this one, the or. So you have pi and 2 pi. So this is pi right here. You have a vertical asymptote. And this is 2 pi. You have a vertical asymptote. So anything that's greater than pi and less than 2 pi, well, here, you're going to be less than 0 in terms of the y values. So that works as well. And again, you can go through and add 2 pi to this. So pi plus 2 pi is 3 pi. So that's going to put you right here. This is 3 pi. And then if you take 2 pi plus 2 pi, that's going to be 4 pi. So this is 4 pi right here. So again, if you look at this piece right here, if you're greater than 3 pi and less than 4 pi, you're going to be good to go again. And you would have this piece right here and so on and so forth. So that's going to be our solution. We're going to go ahead and say that x is greater than or equal to pi over 4 plus 2 pi n and less than or equal to 3 pi over 4 plus 2 pi n. So again, those are included. Then or, and here these are going to be excluded because these are where we're undefined. So we have x is greater than pi plus 2 pi n and less than 2 pi plus 2 pi n. All right, let's take a look at problem number 10. So here we have the cosine of x plus 1 is greater than or equal to negative square root of 3 cosine of x over 2. So the first thing I'm going to do is add square root of 3 cosine of x over 2 to both sides. Let me write that over here. So square root of 3 cosine of x over 2 plus the cosine of x plus 1 is greater than or equal to 0. So let me grab this and come down here and paste this in. So I'm going to solve the related equation first. So let's write out square root of 3 cosine of x over 2 plus the cosine of x plus 1 is equal to 0. Now you could use a half angle formula for this, but if you follow my videos, you know that I don't like that because you end up squaring both sides of your equation and then you have to check. So that slows you down. So basically you can make a substitution here. You can let something like u, so let me let u be equal to x over 2. And then what you can do is you can multiply both sides by 2 and you could say 2u is equal to x. So all I'm going to do is in the place of x over 2, I'm going to write a u. And in the place of x, I'm going to write a 2u. So just like this, and come to a fresh sheet. And we're just going to work on this. So this is going to be in terms of u. So basically, we know that right now, the period for this is 2 pi, and the period for this is pi. So the least common multiple, if you look at it, again, if you have pi and 2 pi, the least common multiple is going to be 2 pi. So solutions here in terms of u are going to repeat every 2 pi. So just keep that in mind. All right, so I am going to replace the cosine of 2u with a little identity. So cosine of 2u, again, you have 3 of these you can pick. So I'm going to use 2 cosine squared u and then minus 1. So I'm just going to plug this right here in for this right here. So that's going to go right there. And again, let me show that this is matching this. All right, so let's say we have the square root of 3 cosine of u and then plus 2 cosine squared u and then minus 1, and then you have your plus 1, and this equals 0. All right, so pretty easy to solve this. Negative 1 plus 1, that'll cancel away. So what I'm going to do is just factor out cosine of u. So if I pull that out, inside you'd have the square root of 3, and then plus you'd have 2. Cosine squared u is cosine of u times cosine of u, so you just have cosine of u here, and then this equals 0. All right, so to solve this, we're going to say cosine of u is equal to 0, or you're going to have square root of 3 plus 2 cosine of u is equal to 0. Subtract the square root of 3 away from each side, so minus the square root of 3, and then divide both sides by 2. So this would be divided by 2 here, and divide by 2 here. That's just going to go away. So let me move this over here. So let me grab this real quick. Let me come down here and paste this in. So let me put a little border here. Again, when you think about it in terms of u, things are going to repeat every 2 pi. So I'm just going to solve this over the interval from 0 to 2 pi. So this is in terms of u. So cosine of u equals 0. So again, where's the cosine value? 0. So it's going to be at pi over 2 and 3 pi over 2. And then cosine of u equals negative square root of 3 over 2. So I'm going into quadrants 2 and 3, and I'm going to find a reference angle of pi over 6. So 5 pi over 6, there's your cosine value of negative square root of 3 over 2. And then 7 pi over 6, there's your cosine value of negative square root of 3 over 2. So let me write that u is equal to, you've got pi over 2, you've got 5 pi over 6, you've got 7 pi over 6, and then you've got 3 pi over 2. So this is actually going to set up 5 intervals. So you can have between 0 and pi over 2, between pi over 2 and 5 pi over 6, between 5 pi over 6 and 7 pi over 6, between 7 pi over 6 and 3 pi over 2, and then between 3 pi over 2 and 2 pi. All right, so coming down here, I've already set up the table. So we're going to work with the inequality in this form. 2 cosine squared u plus square root of 3 cosine of u is greater than or equal to 0. Of course, we know where it's equal to 0 already. We solved the related equation. So pi over 2, 5 pi over 6, 7 pi over 6, and 3 pi over 2. But where is it greater than 0? Again, in each interval, you can just pick something, plug it in, and you're just worried about is it positive or negative. You don't care about the actual value. So here, if you plug in pi over 4, you get about 2.22. So yeah, this would work. Here, if you plug in 3 pi over 4, you get about negative 0.22. That's negative. That won't work. Here, if you plug in pi, you get about 0.27, so that's positive, so that would work. Here, if you plug in 5 pi over 4, you get about negative 0.22, so that's not going to work. And then here, if you plug in 7 pi over 4, you get about 2.22, so that's going to work. Now, this one and this one, you're going to combine that. Remember that this is just set up this way because we solved over the interval from 0 to 2 pi. And basically what you would do is combine those. So it's just going to be from 3 pi over 2, and then this won't be pi over 2. Let me go to the unit circle. Let me get rid of this, and let me highlight the stuff that works so you can see this. I think this is the trickiest part. So basically we know that this right here, so between 3 pi over 2 and this guy right here, which will not be pi over 2, again, because if I'm starting here and I'm rotating here, this is not pi over 2, it's pi over 2 plus 2 pi, so that's basically going to be 5 pi over 2. Now, these would both be included because it's a non-strict inequality. So remember, this is in terms of u. So let me write u is greater than or equal to, let's go ahead and put our 3 pi over 2 plus 2 pi n, and it's less than or equal to, again, instead of this being pi over 2, you go pi over 2 plus 4 pi over 2. So that's 5 pi over 2. So let's put 5 pi over 2 plus 2 pi n. Okay, let me get rid of this. Now, we've done enough of these problems to know that if you wanted to, you could rotate clockwise here and say this is negative pi over 2. If you wanted to put negative pi over 2 here and pi over 2 here, that's fine. That will work for the solution in terms of u. So let's go ahead and put, or we need the other part, and that's going to be this part right here. So basically, from 5 pi over 6 to 7 pi over 6, and again, those are both going to be included. So I'm going to say that u is greater than or equal to 5 pi over 6 plus 2. Let me scooch this down. So 2 pi n. And then it's going to be and less than or equal to your 7 pi over 6 plus 2 pi n. Okay, let's come back here and let me put a little border. Remember that u is x over 2. So all you have to do is plug in an x over 2 here. So let's put x over 2 and then x over 2. Now, if you want to solve for x, you're going to multiply everything by 2. That's all you have to do. So let me slide down here, and I'm just going to start. So we're going to write out 3 pi over 2 times 2 plus 2 times 2 pi n is less than or equal to, let me make that a lot better there. We'll have x over 2 times 2, which is less than or equal to 5 pi over 2 times 2 plus 2 pi n times 2. So this cancels. You're going to get 3 pi, and then plus this would be 4 pi n. Let me make this 3 a little bit better there. And then this would be less than or equal to, this cancels, so this is x, which is less than or equal to, the 2's cancel, so you're going to get 5 pi plus 2 pi n times 2 is 4 pi n. Okay, let me get rid of this. So that's part of your solution. Let me drag this up here, and then let me put or. So the other one is going to be coming from this right here. Again, you're just going to multiply everything by 2. So you're going to have 5 pi over 6 times 2 plus 2 times 2 pi n. So this is less than or equal to x over 2 times 2, which is less than or equal to, you have 7 pi over 6 times 2 plus 2 pi n times 2. Again, coming through here, so 6 divided by 2 is 3. So that's going to be 5 pi over 3. Let me write this down here. So let me write 5 pi over 3, and then plus 2 times 2 is 4, so this is 4 pi n. So this is going to be less than or equal to, the 2's cancel, so this is just x, which is less than or equal to, 6 divided by 2 again is 3, so this is 7 pi over 3, and then plus 2 times 2 is 4, so this is 4 pi n. Okay, let me get rid of this, and this right here is our final solution. So let me grab this, let me paste this in here. So we're graphing y equals cosine of x plus square root of 3 cosine of x over 2 plus 1. When we think about the period of this guy, it's going to be 4 pi. The period of the cosine of x is 2 pi. The period of the cosine of x over 2 is 4 pi. So you want the least common multiple of that. So the LCM of 2 pi and 4 pi is 4 pi. So that's why you have this plus 4 pi n all over the place here. So we want to figure out where the y values are going to be greater than or equal to 0. So at 3 pi, it's equal to 0. At 5 pi, it's equal to 0. And again, if I look between, my y values are greater than 0. So that's going to work there. Now I'm going to go this way because I don't have enough information this way. The graph is just not long enough for me. You can do this on Desmos if you want. But basically I'm going to subtract 4 pi away from each part. So 3 pi minus 4 pi is negative pi. So that would be negative pi right there. And then if you do 5 pi minus 4 pi, that's going to be pi. So right there. So that's another piece. So here the y values again are greater than 0. So you could have also written this and said, well, it's negative pi plus 4 pi n, which is less than or equal to x, which is less than or equal to, it would be pi plus 4 pi n. So another way to write that part. Now for the other part, we're looking at 5 pi over 3, so that's right there. And then we have 7 pi over 3, so that's right there. So basically you're 0 at those values, and then between them, your y values are greater than 0. So that would work. Again, if you subtract away 4 pi from each part, well, 5 pi over 3 minus, let's go 12 pi over 3. That would be negative 7 pi over 3. So that's going to put you right here. And then if you go 7 pi over 3 minus 12 pi over 3, that's going to be negative 5 pi over 3. So that's going to put you right there. So again, this piece right here. So you could have written it like that as well. So I'm just going to go with the solution as given. So we have x is greater than or equal to 3 pi plus 4 pi n and less than or equal to 5 pi plus 4 pi n. Then or you have x is greater than or equal to 5 pi over 3 plus 4 pi n and less than or equal to 7 pi over 3 plus 4 pi n, where n is any integer.